10 times the exponent of this. So
Alright,
1,
so
2,
my
and
end number was
then 4 more, which adds 4 zeros at the end.
So when you do 10 to the power of 2,
no, this is not a part
you're
number.
just adding another 0 to that. And then 100 times 34,500, we're just adding 2 zeros.
Yeah. 3,045,000. That's 3,450,000. Sorry. So do we have to do the homework on the document? Okay, well, I marked you as done. I have you.
Wait, hang on, we all right? Yeah. Okay. Good job. You don't have to do. If you guys can figure out the pattern, right?
What you did first?
Oh, we were supposed to put the things over there.
So tell me what did you do first?
So, since it said it was 34.5 and you're multiplying it by 10 to the 5th power, I automatically assumed that you'd have to do like move or 6. I moved it 6 times.
Now you have to answer those two questions.
Oh, no.
Alright,
I was
which
wrong.
number is
Yeah,
first?
5. Because I
Elena,
overthought
your
for
group's
a
supposed to
second.
be answering those
So
questions.
if we made it 5, it'd be 1, 2.
Then it'd be 3 million.
There you go. I never heard it.
You're supposed to be discussing the two questions.
Yes, if you have finished, you need to be discussing those two questions with your group.
The top of line.
Both.
Number of expression 5 the 10 to the power of 9 on ours. That's the 10 to the
Where'd the 5 go? What? 5. Where'd the 5 go?
Oh, I'm sorry. 5.
And then, so, what do the numbers have in common? Well, the numbers are all the same.
There you have that.
Right.
Okay, so we're going to come back together and talk about this as a group, okay? So, first of all, I want your group to share with me, how did you do this?
So we did 34,500 on the end
Okay,
times 10 to the power of 2.
okay,
So when you're doing 10 with exponents, the exponent, like, you just add another 0 to the end. So 10 to the power of 2 is 100. And then when you multiply 34,500 times 100, you just add just another 0.
does anyone agree with what Elena said? Yeah, Dan?
I agree in total because we did the exact same thing with that.
Okay.
We just figured out what 10 to the power of 4 was.
Did anyone do it a different way? Yeah. Okay, okay. Can someone repeat what she said? What did she do? Yeah.
She moved the zero 6 times.
Yeah. So what do we notice about all of these numbers once we converted them to a standard number?
Literally the same thing.
They're all the same. But they're expressed in different ways, right? So which of these is scientific notation? All of them.
No, it's not all.
What do you think?
It's not all of them because, like, for example, 3.45 times 10 to the power of 6, you can only move decimal twice in sign.
Say that one more time.
So, correct me if I'm wrong because I just learned what this was, but scientific notation is when you move it all the way from the end to the front and you add however many times you did the little bunny hops on the bottom. You
Okay.
make that your exponent.
Okay.
So,
But didn't we do that on all of them? How do you know that this one, which one would be? How do you know which one would be? Which one are you saying is scientific notation?
I don't know, but I just know this.
Okay. It's okay. We're just getting some ideas.
Okay, guess say the middle one is scientific notation.
This one right here.
Yes.
Anyone have any other ideas? These are all good ideas. So what about the video we just watched? Over and over you saw a number and you saw them do the bunny hops.
Right.
Where did the decimal end up?
At the end,
The beginning.
Beginning. After which number?
the first
The
one.
first number. So which of these has a decimal after the first number?
3.4.
The
Is that not the one that I used as an example?
3.45 times 10 to the 6. This one would be written in scientific notation. All of these numbers are equivalent, but this one is how you would write it because the decimal is after the first significant digit. Significant digit is a non-zero number. Yeah.
So you specifically have to have that decimal for it to be scientific notation? Yes.
All right. So here, what they did was multiply 10 by itself 6 times. And then they multiplied it here. Or you could just move the decimal from here 6 places to the right, which got you to right there. So if you look at this anchor chart right here, scientific notation, as we've already said, is a compact way of writing very large or very small numbers. So I gave this example. Can y'all see this over here? If you need to move for a second, you can. So the distance from Earth to the Sun is 150 billion meters. So what if you were given a problem that said, compare the distance between, or compare this distance between another distance? You're going to have 2 huge numbers, right? And that's really hard to work with. So there's easier ways to work with numbers like this. So step 1, as you guys told me, we're going to put a decimal to the right of the first significant digit. Then we're going to count how many places there are from the decimal to the very end of the number. So I showed you that here. We start here and we count 11 places. So then, you're almost done, you have to decide whether your exponent is going to be negative or positive. So if you look back at your original number and it's positive, or if it's greater than 1, every time your exponent is going to be positive. We've already learned about negative exponents, right? When you have a negative exponent, what do you get? A fraction. So if you have a number that's less than 1, or between 0 and 1, your exponent is going to be what? Positive or negative?
Negative.
If you have your original number between 0 and 1,
Oh.
which means it's a fraction, you're going to have negative exponent. So larger numbers, positive exponents. Smaller numbers, negative exponents. So this is your coefficient, and it's always going to be between 1 and 10, or it could be 1, between 1 and 10. Your decimal is going to go after the first number. You're going to have a multiplication sign. Your base is always going to be 10 in scientific notation. And you're going to have a power of 10. And this is how many places that you move your decimal. So if we went backwards and we added 11 places to this right here, we counted 11 over, we would end back up with this number. Kind of make sense? Okay, so I'm going to give you a note-taking guide. Take out your notebooks.